Flack math! Give me some math and I'll give you some flack. Flack math!
We are going to talk about a cool dude named Pythagoras. And he came up with a theorem called the Pythagorean Theorem. I thought I remembered talking to you guys about the Pythagorean Theorem, but maybe not. Did I? Did I talk to you guys about it? I don't think so. Maybe.
B squared equals C squared? No? Yes?
Was that, who did I talk, was that pre-algebra, Mrs. Waite, that we did Pythagorean triples?
Yeah, I think it was. I think it was.
All right. All the classes get kind of mushed together.
You can see that.
All right, so here's what Pythagoras said. He said, in a right triangle, that if you were to create squares out of the sides of these right triangles, that's kind of a square, then the area of these squares would be the sum of the areas of the legs squares would be equal to the sum of the hypotenuse. Okay, so this guy is our hypotenuse. And this is a leg, and this is a leg. So the two legs are the sides of the right angle of the right triangle. The hypotenuse is the one that's across the pond from the right angle. Okay. So here's what he said. If we call this A, we call this B, and we call this C, to find the area of this square, it's just A squared, right? To find the area of this, it's just B times itself, which is B squared. And this is C squared. So he said that A squared plus B squared equals C squared. All right, there is a misquote in The Wizard of Oz. Whoever wrote The Wizard of Oz was not a mathematician. But when the Scarecrow got his brain, you know what he said? He said, what did he say? The
sum of something.
Sum of the squares of the two sides of an isosceles triangle is equal to the third side square. And then he's like, but he said isosceles triangle. He should have said right triangle. So he apparently the brain that he got was a little bit messed up. So the brain that the Scarecrow got was not sufficient. So don't let that keep you from enjoying The Wizard of Oz. I mean, I'm sure it's a good movie in other ways, but mathematically it's embarrassing. Okay? So I'm sure the Scarecrow has other good qualities, but brains is not one of them, unfortunately. So here's the deal. If we are given 2 out of the 3 sides of a right triangle, then we can figure out the third. Let's see if we can do that. So here is a triangle. And let's say that this guy is 6 and this guy is 8. And I want to find this third side. Okay? So I would suggest the first thing you should always do is just write the theorem. A squared plus B squared equals C squared. So remember, these guys have to be the legs. And it doesn't matter which leg goes where. The only thing that matters is that the hypotenuse is by itself on one side. So the sum of the squares of the two legs equals the square of the hypotenuse. Okay. So which one's the hypotenuse? Well, it's drawn just like this example. So so that's pretty easy. So this time instead of A, we're going to say 6. And instead of B, we're going to say 8. And C is C, so we're just going to leave it C squared. Now we could have said 8 squared plus 6 squared. It doesn't matter, right? So what's 6 squared? What is that? Shout it out.
36.
36. And what's 8 squared?
64.
64. And that has to equal C squared. So 100 equals C squared. So did we just find C?
No.
Not yet. So if c squared is 100, what's c? I hear squeaking. Right. So what you can do, basically, you just have to square root both sides. Okay, and that cancels that. So it's just like solving an equation. You have to get rid of this little 2, do the opposite operation. The opposite of squaring something is square rooting something. So c equals 10. Cool. All right, let's try another example. Let's see if you guys can do one, okay? I'm having page turning issues here. All right, ready? Here's example 2. All right, let's find A. See if you guys can find what A is. And it's going to come out really nice. It's not going to be weird at all.
I don't know how you guys can figure anything out. Nobody has a paper out.
I know, you guys are just sitting there with your hands on your knees, very respectfully, but you look bored.
Yeah. It'll help you if you get a paper up. Yeah.
Somebody got an answer?
No, I'm working on it though. Is it 5?
Maybe. What
Is
did you
it
guys
5? I think I got. Yeah, I got 5 too.
All right,
I think I'm
let's
doing the wrong
yeah.
one.
So we're going to write first things first. A squared plus b squared equals c squared. And it's important to remember that this only works with right triangles. So right triangles have this special relationship where the leg squared plus leg squared equals hypotenuse squared, okay? So it doesn't matter which is which, but since this is already labeled A, let's just call A. And then 12 squared. And then the hardest part about these problems, guys, is trying to figure out which one's the hypotenuse. So it's always the longest side, but it's the one that's opposite of the right angle. The one that's not the legs. The legs are the sides of the right angle, okay? So let's see, a squared plus 144 equals 169. Get rid of 144. We're trying to get A. Okay, so a squared equals 25. Well, if a squared equals 25, that means the square root of a squared, which is a, equals 5. Good job. All right, so
Yay!
good job. You should be very proud of yourself. Now, this is what your homework might do. It might say, okay, example 3, I want to find the perimeter of this triangle. Okay, so here's a triangle. Oops. I want to find the perimeter of this triangle. So how do we do that? How do you find the perimeter? What do you do? Adeline knows, but anyone else? What do you do?
You add all the sides.
Is that anyone else? All right, so we have
Not
3
really.
plus 4 plus this mystery.
Nobody has their hand up.
Okay, so how do you find that third side, Adeline? Yep.
A squared plus B squared
All right.
equals C squared.
Pythagorean theorem. Pythagorean theorem. It's fun to say if you want to try it. So a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. So c equals 5. But don't be done there. Don't forget that you have another question you have to answer, the perimeter. So now we can add the sides and we get 12. So we'll call them centimeters.
Oh.
Okay. So that is the Pythagorean theorem. Okay. The other thing that it's going to do is it's going to ask you if such and such is a right triangle. Well, the way you figure that out is if it works in the Pythagorean theorem, if the Pythagorean theorem works with those sides, then it's a right triangle. Okay. So be careful on what they might ask you. Okay. So, any questions on the Pythagorean theorem? That's a big word. So that means that sounds
You say it
like
5 times fast.
smart thing. What's that? I get 5 points?
You say it 5 times. No, can you say it 5 times fast?
Oh, Pythagorean theorem, Pythagorean theorem, Pythagorean theorem. It is difficult. Okay, let's do this. Ready? Ready for this? Lesson 100. That's crazy. So this last lesson that we're going to talk about is on estimating square roots. Okay, now not every number is square rootable, right? But like square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. So there's certain numbers that are square rootable, but look, what about the square root of 10? What times itself equals 10? Don't say 5. What times itself equals 10? Well, that would be, let's see, like 2 times itself is 4, 3 times itself is 9, 4 times itself is 16. So that means it's somewhere between 3 and 4. So it's 3 point something. Right? Something. So do you see how I got 3 point something? Because 3 squared would equal 9, 4 squared equals 16. So it's somewhere in between 3 and 4. So if I use my brain calculator and I were to plug this into the calculator, it would probably say 3 point something. Okay. So now this is actually going to be an irrational number. So the questions that you are going to be asked is, in between what 2 counting numbers is the square root of 10? So we would say this is between 3 and 4. Or here's how the cool kids are doing it. So 3 is less than the square root of 10, which is less than 4. This is a cool way to say in between 3 and 4. You see how it's in between it? Because it's greater than 3. So the alligator eats that. And then it's less than 4. All right. All right. See if you can do this. Between what 2 numbers is the square root of 29? What's that?
I'm thinking.
Yeah,
Oh,
go Hunter.
Between 5 and 6.
Yes, Hunter says 5 and 6.
All right, because the square root of 25 is 5. The square root of 36 is 6. So the square root of 29 is in between 5 and 6. Okay? So different people do this different ways. But if you were to guesstimate, if you were going to guess on what your calculator would say, remember that whenever you're finding the square root of something, you're asking yourself what number times itself equals 29. Okay, well, you know, 5 times itself equals 25, 6 times itself equals 36, so it has to be in between 5 and 6. Okay, now if I were to graph this, let's see here, in between 5 and 6, it would probably end up being about right there. Okay. So you don't really have to graph it, but that's just kind of a visual of what's happening. All right, let's try another one. Here's example 1. I want to figure out what the square root of 200 is in between. Go for it.
Go ahead, Ellen.
10 and 11.
Nope. 10 squared is 100, right? And 11 squared is 121, so it's got to be bigger than that.
So, is it between 13 and 14? That's what I'm saying.
No, getting closer.
Is it between 14 and 15?
Yes, it is. Okay, so here's the deal. So you can try these different things. Like I would try like 10 squared equals 100. 20 squared equals 400. So it's in between 10 and 20. And those are the easy ones, right? So let's see here. It's got to be less than 20. So what about 15? 15 squared is 225. That's just too big. So 14 squared is 196. So look at that. It's in between there. So 200 is in between there. So that means it's in between 14 and 15. Okay. Now you could keep going. You could try to figure out what 2/10 is it in between. Okay. So you could try to figure out if it's, okay, well, 14.1-ish. Okay, well, 14.1-ish squared, that could be pretty close because it's almost, because 14 squared was almost 200, right? So it could be 14.0 something or 14.1 something maybe. That's just guessing, but you can always test it. So these are just trial and error questions. So you have to try something and then see if it works. Okay. So at the beginning of the lesson, we found that square root of 29 is in between 5 and 6. We can refine our estimate. Okay. So remember, let's go down here. So square root of 29 is in between 5 and 6. Well, let's see if we can find the nearest tenth, or not nearest tenth, but in between what 2/10. Okay. So let's try 5.4. So when we multiply 5.4 times itself, we get 29.16. So that's too large. Okay. Got to go up to 29. So let's try 5.3. You multiply that, you get 28.09. So it looks like it's in between 5.3 and 5.4. Okay, and then you could keep going from there. You could try to figure out what 200ths it's in between. All right, but most of the time, and on your homework, it's probably just going to ask you for in between what two integers. So remember, integers are all the whole numbers and their opposites, okay? All right. So, and again, if you use a calculator and you type in the square root of 29, or it'll give you 5.385164.8. So this ends up being what we call an irrational number. You guys remember what other number is an irrational number? So irrational. We didn't really talk too much about
200.
So 200 is the square root of 200 is irrational, yes. But irrational numbers have never ending, never repeating decimals. So what number is an example of a never ending, never repeating decimal? And we skipped it
A
this year.
very sad number.
We skipped it. What day did we skip this year? And
Pi?
yes, pi is approximately 3.14159, and that's where Mr. Flack draws the line. Okay, so this number goes on forever. There's no pattern. People dedicate their lives to try to find patterns in this number and memorize digits. Don't be one of those people, okay? There's a beautiful world out there that has nothing to do, well, it has a lot to do with pi, but don't be that type of person who memorizes digits of pi, unless you get a $10 gift card for memorizing a bunch of numbers like we were supposed to do this year, but we didn't. Stinking COVID. Okay, so these are irrational numbers. Whenever you try to take the square root of something that's not square rootable, like 29, you get an irrational number. And I have to say that little approximation because this number will go on forever and ever and never repeat. So you can count on that. When you take the square root of something that's not square rootable, then you will end up with a never ending, never repeating decimal, an irrational number. Okay? All right, let's try something here. We're going to apply what we learned in our last lesson. Let's see if we can find this third side. Anyone know what that is?
Five point
Okay, yeah, yeah. So the answer is right there, isn't it?
5.8.
Good. So if I use the
5.38.
Pythagorean Theorem, we get 2 squared plus 5 squared equals c squared. So that's 4 plus 25 equals c squared. So 29 equals c squared. C equals what? The square root of 29. Do you know the best way to say the square root of 29? The square root of 29. That's the best way to say the square root of 29, because that's the most exact answer. Because if you try to turn this into a decimal, you will be there for the rest of eternity. Listing digits, right? 5.38516. That's not how I want to spend my eternity. Okay? So the best way to say the square root of 29 is the square root of 29. So the answer is the square root of 29 centimeters. And that's a weird thing to say, but that's the most exact way to say it. Okay? Now, if you were building a house, you can't say square root of 29. You'd have to round it to something like 5.39 or 5.385. You would have to round it. But this is the most exact way to say the square root of 29 is just the square root of 29. Okay? All right, so the rest of this lesson talks about rational and irrational numbers. we've got a big set of real numbers, but underneath the set of real numbers, there's two different types of numbers. There's irrational numbers, and then there's rational numbers. Rational numbers are the numbers that we are familiar with. They're all fractions and decimals that either repeat or they stop, right? So rational numbers, and then you've got your integers, which are all the whole numbers and their opposites. So 1, 2, 3, 4, 5, and also 0, and -1, -2, -3, -4, -5. Then you got your whole numbers, which are all the counting numbers plus 0, right? So this is where most of our friendly numbers reside. These are the weirdos. This is like pi and like square root of 10 and a bunch of other stuff. There's another number called e that we'll talk about in algebra 2. But there's a bunch of different weird numbers over here in the irrational section, okay? But counting numbers, so counting numbers are rational numbers. So counting numbers are everything above it. Whole numbers, integers, rational numbers. Whole numbers are integers, rational numbers, and real numbers. But so it's kind of like a Venn diagram. You guys remember seeing these where if I broke this up into two sections, this is my real numbers. Here's my irrats. And here's my rats. And inside the rats, there's integers. This is called a Venn diagram. And inside the integers, there's the whole numbers. And inside the whole numbers, there's natural numbers or counting numbers. Okay. So these numbers are like 3/4 or -2/3 or whatever. And then integers are like -1, -2, -3. And then whole numbers are 0. Natural numbers are 1, 2, 3. Okay. And then here's my irrats, which is pi, square root of 10 or whatever, square root of anything that's not square rootable. Okay. So we're going to talk about these subsets of real numbers in another class to come. But for now, you just need to be able to recognize which numbers are rational numbers and which numbers are irrational numbers. Okay. So, on a number line, like some of these guys are a little weird, but on a number line, 3.14, like this right here, this would be a pi right here, right? And then the square root of 2, let's see, the square root of 2 is, let's see, it's 1 point something. So you could put like the square root of 2 like right here. Okay. So you need to know how to put these numbers on a number line or trying to estimate in between what two numbers there are. So for example, if remember it was in between 5 and 6, that square root of 29, right? So here's like that square root of 29 is like 5.3 something. So see where that fits on a number line. So you need to be able to place these numbers as best as you can. But that's it. So we'll go into this in other classes to come, but that's basically it for 7th grade math. So well done, you guys. You guys have any questions?
I have a comment. I can't believe that we're already at less than 100.
I know, it is crazy. We did 100 lessons. And if we would have done all the problem sets, that's like, what is that? 30 times 100. What's 30 times 100? That's a lot of problems. So we didn't, that's, what is that? 3,000? Am I doing that math right? 3,000 problems this year? Well, we skipped a few problem sets. So maybe 2,000 problems this year is what you guys did. That's pretty good. So, Grace, are you looking out the window?
Yep.
Every time I I'm zooming. You're always looking out the window. Not that you shouldn't.
No, she does that.
I'm sure C470 is very beautiful this time of day. But you always have that profile look. I'm like, what is she doing? What is she thinking about? What is Grace thinking about? All right. Well, guess we'll have to figure that out. So that's it. Any questions or other observations?
Black math, give me some math and I'll give you some flack. Black math.